Hello, this is going to be a quick little lecture on free fall. Free fall is when a projectile or object is under only the force of gravity. So we only are concerned with the downward acceleration of gravity, which in this case is because it's downward, 9.8 meters per second squared. Throughout this, we're really only going to be concerned with objects for this first part of objects in one dimension, so something tossed straight up. If we look at something like that, it's tossed straight up in the air, straight line, I can sort of draw that. Its speed throughout this whole time is slowing down, so here it's slowing down. It then reaches the top of its flight here and changes direction. At this point, when it changes direction, the velocity is 0. Now, the velocity and the acceleration are in the same direction, so the object, as it falls back down, will be speeding up. This is, get back in there. It's a little, I'm getting used to the camera. Hopefully things are going to start to go a little better and smoother as we go on. But this is just a general overview. Let's look at it for something launched up in the air, straight up, and break it down into individual seconds. So here's Mr. Wolf, little stick figure, and he throws a ball up in the air. Now for this drawing, I'm going to assume that it goes up in the air and comes back down. Don't be concerned with it as I move across to the right or to the left. Just be concerned, think of it as just going up in the air and coming straight back down, as if I was just merely tossing this marker straight up. So, its initial velocity. Let's give it some random number. Let's say it leaves my hand at 30 meters per second. So here's the projectile, its velocity, and we're going to draw this velocity in green. (30 meters per second). It's also a positive velocity, so it's going upward. Now, throughout here, there are going to be two equations that we're really going to look at and need to use. The first one is going to be concerned with velocity. This equation here says final velocity, or current velocity, is equal to the initial velocity plus the acceleration multiplied by time. In our case, acceleration is going to be negative. So we can add that in later. The acceleration is the same as g. Sometimes you will see it written that way. The other formula that we're going to be worried about is going to be concerning distance. Now normally the distance equation is written with an x, but for this, since we're looking at just the y velocity, y direction, up and down, I'm going to write y. So final position is equal to initial position plus initial velocity multiplied by time plus 1/2 acceleration multiplied by time squared. I need to write that in a better place. And put it down here. All right. So here we have our two equations that we're really going to be worried about, and we have our projectile. We have some initial conditions too. Already from this, we're going to say our initial velocity, v0, is 30 meters per second squared. So I will start writing these initial conditions up here. V naught is equal to 30 meters per second. Our initial position, y naught, is going to be 0. Just makes it easy. We'll start there at point 0. Sometimes you may have a different initial position, say if something's up on top of a cliff or something like that, different for different problems. And finally, our acceleration. Our acceleration is going to be the same as gravity. It's the only force acting on this object. Now, 9.8 meters per second squared, negative 9.8 meters per second squared because it's directed downward. For this demonstration and for this, purely just to make it a little bit simpler, I'm going to use 10. Just a little rounding, make it a little bit easier. All right, so here we have our initial launch. We know at this point here, time is equal to 0 seconds. All right? Time is equal to 0 seconds. Now, let's look at what happens after 1 second. So at this point, the projectile has traveled up some distance. It's been slowing down. After 1 second, what would be its velocity?